Afternoon. Low power wireless networks are the hypey thing at the moment, and there's quite a few of them around. So SIGFOX was started by a French group, which was, I guess, the special interest group on they don't know why they called it Fox. It's an open standard, so they've published all the radio bits and how to do chips, so anyone can do it. It's based on ultra narrowband signaling, so it sends very short bursts out. You can send 12 byte messages, but only 140 per day, and that's from the end user equipment to the network. And the network can only send 4 messages out per day back to an end user, and it's a user's bitpack format. So in that in those 12 bytes, you can specify whatever data you want in there, but it will just come out as 12 bytes, and you have to decode it knowing what you've put in the other end. Then there's LoRa, which is what lots of people are trying to do now. It's a specification that was originally came out of Semtech, the chip company, not the explosive. It's a space spectrum technology, so it broadcasts on multiple channels at once. And again, it's low power, and it uses different data rates depending on how close or far away you are from the gateways. So and they're actually called SF. There's actually an SF6, but it's not usable. But SF7 to SF12. Where an SF7 packet will correspond to 51 usable bytes, and an SF12 to 212 usable bytes. There's also the packet header and stuff in there which you have to account for. And there's 3 modes of operation. Class A, which is basically a chirp, a lower type protocol, which goes hello. Class B just puts extra windows on the receiving equipment or the node, and puts extra receive windows there so it can receive stuff back. But that obviously takes higher power because you're leaving the receive channels on, or the receive radio on, for longer. And then Class C is always listening except when it's transmitting. The way it's set up in the European bands, although it's based on 868, actually Class C operates in 869, which gives you interesting things where, because Class A is based on 868, so you have a 25 milliwatt ERP, which is strange for UK because everything is EIRP, but because it's a European or ETSI standard, it's ERP, so you can use directional aerials to increase the gain. But if you're a Class C equipment, you must also operate in Class A mode, as in also Class B, so you also operate Class A. So even though you can use these high frequencies at the higher rates, it means you'd always have to be able to fall back to Class A, which means you could only go back to 25 milliwatts. So although you can use 500 milliwatts in Class C, you couldn't actually use it in real terms. Then we got Weightless, which is the Weightless Weightless SIG organization, Weightless N, Weightless P, and Weightless W. They're all, again, ultra narrowband, except for Weightless N, Weightless W. Although they're all done by the Weightless group, for some reason they've moved from Weightless N and now promoting Weightless P quite significantly. And then there's various 3GPP standards, including NBIOT, which is sort of around now. I think Vodafone have launched one in Holland or somewhere. LTM, which is coming out. Again, there are very early stage implementations of it, but they're all SIM-based, and carriers obviously want to charge you per packet. So there's also lots of other ones. I think the most common ones are 802.15.4.1 base, which is Thread, and Zigbee, which use the same physical chipset, or chip, or physical medium, I should say. Then you've got Z-Wave, and now Bluetooth 5, and recently people have done tests with Bluetooth 5, and in free space, so this was on a mountain, literally going out over nothing, they did get up to just under a kilometre. So, and that's Bluetooth 5 is out now and has been ratified. In the UK, SIGFOX is actually run by Arqiva. It's around various cities. If you go to Arqiva to try and get any information, you'll do it under NDA, and it's a pain having tried to do it. They don't really understand speaking to small companies and small businesses and whoever else, and so just go to makers.sigfox.com and they've got all the information there, which chipsets are available and how you can use it, and they've even got a trial service that you can use there. Things Connected is a new service that's being run by Digital Catapult, based in Euston. They're rolling out 50 sites in London, and they are utilising SMS, so you have to verify your phone number to say who you are before you can register to use the service, and then you can register equipment on there. And they're doing that in cooperation with various people, including BT, that's mainly to put on their buildings, and Everynet, who happen to be a supplier of LoRa gateways. Weightless N is being rolled out by N-Wave. It's available in London, and you can get dev kits, and they're available now. And again, they're actually quite easy to talk to, and be happy to talk to people who are looking to do stuff. Things Network is the potentially disruptive one. They ran a Kickstarter to run a gateway, a node, and an Arduino piece of kit. There's lots of open source stuff out there. They've built a back-end, what they call network router. They allow anyone to register, and they allow anyone to put to register a back-end service, and anyone to register a piece of hardware. The only authentication they have is an email, and they don't really care where you come from. The gateways are all sat on consumer or business existing internet connections, which may not sound a lot, but potentially a gateway can handle up to 10,000 nodes, and if you've got 10,000 nodes sending a lot of information, or even though you're limited to how much you can send, so what they've done is a fair use policy where you can do 30 seconds transmit to the network per day, so that 30 seconds is the actual amount you're actually physically transmitting, and that includes the size of your payload plus all the headers. It is encrypted end-to-end, so a gateway operator doesn't know what traffic is passing through. However, there are real interesting legal issues, because the Things Network potentially will have hundreds of thousands of nodes connecting through it. So who owns the network is a potentially interesting topic, and then who has the legal responsibility for anything going through the network is another one. So if you're a consumer and you go, I think I want to run a Things Network gateway, you can just order a gateway. They're a couple of $100, shove it on your existing connection, put an aerial out there, and you can have thousands of nodes connecting through you. I would say under the UK IP Act that you would be liable for running a node, potentially running a node in the UK, but it's going to be interesting to see what happens with that one. And then there are just a quick thing about the legalities of this all. Up until recently, anything on the Things Network, for example, wasn't CE marked, therefore it is illegal to use. And Spectrum in the UK is covered by the Wireless Telegraphy Act 2006. You need a license to receive or broadcast on any piece of spectrum in the UK. There is no such thing as license-free spectrum as there is in the US and other countries. And the WTA is extremely punitive compared to the crime of having unlicensed equipment or licensed equipment that you can either receive or transmit. That was because in 1900s, it was much easier to catch spies by proving they had radio equipment than proving they were spying. So literally our first offence, in theory, first offences can be up to 25 years. So it's extremely punitive. There are license-exempt bands, like 2.4 gigahertz, for example, which means that if you abide by that ban, the license that Ofcom has published, you don't need a specific license, and in most of these bands you wouldn't ever get a specific license. And all license-exempt spectrum has gone through an Act of Parliament. So, in terms of the 868 licensing, there is a ETSI regulation, which is EN 300-220, or the IR 2030, which is the UK SI that was published. But it does state all equipment must be CE marked. You cannot sell equipment that isn't CE marked, and people are obviously doing that, and that's actually a criminal offence. And if you want to run test stuff, your node that you're communicating must be less than 100 metres apart. So if you wanted to run on a nice LoRa network using a Pi and various kit that you can buy off the internet, you could run that pretty much in this room. But if you put something on the roof and have people accessing it from greater than 100 metres, you are again breaking the law, and that's a potential first offence. Now they tend to fine you about £5,000 and 2 years in jail up to. So you can run a test network, but then you have to apply for a test licence, and that costs you £50 per node. And they're actually quite easy to get hold of, but just very few people do them. And that's about it. Thank you.
Do we have a question or two for Steve?
Easy. Yep.
Is there a microphone up there?
It's on its way.
Thank you. The technology is fascinating, but can you give us some real-world use cases for what we can actually do with this?
So if you're running any kind of IoT, like sensor readings, they pretty much can all be used for putting a sensor out in the wild. If you have, say, SIGFOX or LoRa, in theory, if you're only transmitting data irregularly, you know, the actual LoRa kit will run off a coin cell for, they say, up to 10 years, but they are very low power, because they literally just send a 25 milliwatt pulse and then go back to sleep. And if you're doing, say, sending something once an hour, you are really using.
So it's sort of meter readings.
Yeah, well, meter readings is there's. I mean, SIGFOX are doing a lot of stuff. I mean, Arqiva run meter reading services, but they don't actually use SIGFOX at the moment. But you could use SIGFOX to easily do meter readings. Yeah.
Thank you.
Although then you're not so worried about low power, because you've got power there. It's more useful for sort of if you're doing stuff in remote areas where you don't actually have access to stuff that you can plug into the mains.
Okay, thanks very much, Steve.